This is inverse functions. I need to make the screen bigger. All right, inverse functions. When you're taking, let's just talk about, before we talk about functions, let's talk about points, okay? If you're taking a point, like the point, I'm going to do 1, 2, 3, 4. Let's do the point 4, comma 1. If I'm taking that point and I'm inverting that point, to invert something means to like switch it around, okay? So to invert the point 4, 1, you're going to take and you're going to switch those two coordinates around to make it 1, 4. And it's going to be this point up here, 1, comma 4. You're taking the x coordinates and you're switching them. The xy becomes yx. That's what an inverse does. Inverse takes the xy coordinates and moves them to y comma x, okay? Now, with functions, it's doing the same thing. All your xy's become yx's, okay? And you'll notice that, this is important, you'll notice that on the graph of a function, if two functions are inverses of each other, they are reflections of each other across the line y equals x. If I take this point right here and reflect him this way, he becomes the point 1, comma 4, okay? That's what the graph of functions do if they are inverses. They're reflections across this magical line called y equals x, okay? All right, so the first example, graphing an inverse relationship. The graph of a function f is shown below. Graph the inverse, okay? The first time you do this, it might be better just to take the points and flip them around. So this first point, 0, 0, if you flip around 0, 0, it doesn't change, right? Okay? This point 1, 1, if you flip the point 1, 1 around, it doesn't change, okay? Let's go to negative 1, 1. That, if we flip it around, will become 1, negative 1, and he'll be down here. Down here. 1, negative 1. 1, comma, negative 1, if you can write really small. Then you have the point 2, 4. That will become 4, 2. 4, comma, 2. You don't have to write the ordered pairs in there if you don't want to. Okay, 4, comma, 2. Blurry. Negative 2, 4 will become 4, negative 2, right here. Then we have 3, comma, 9. 3, 9 will become 9, 3. So about there, and then we'll have 9, negative 3. So we'll have a parabola that looks like this, okay, laying on its side, all right? Some of you might already know that. This is the graph of y equals x squared. His inverse, what's that function look like? What's the function that's associated with the green one?
Y squared.
X equals y squared. You're basically switching the x's and y's around, just like I just said, right? X equals y squared and y equals x squared are exactly the same thing, okay? Let's see, anything else I can say about that? Yeah, this dotted line right here, that's magical y equals x line. If I take this guy and reflect him over here, he becomes that parabola. Those are reflected across that magical line y equals x, just like I just said. Okay? But the x's and y's, they just basically like flip around. Okay? Now, when you're given other functions, there are steps to switching these functions around, and I've taught you these steps in like algebra. I think we did them in geometry probably too. So there's 4 steps to finding an inverse. Some of you guys skip the first step and go straight to the second step, and that's okay. The first step, you change f of x to y. You change your f of x to y. Do you remember these steps? Remember doing this? Yeah. And then you switch x and y around, okay? X and y interchange with each other. Do you remember what the third step was? After you switch x and y around, what do you do for the third step? Solve for y. And then you're going to take y and you're going to change it back to, this time, f inverse of x. F inverse of x. That's how it's read. F inverse of x. That's what that thing says. Okay? So you switch them around, you do all that stuff. Great. Okay? All right, moving on. Finding the inverse. So they want us to find g of x, which is the inverse of f of x. Okay? So now we're going to be calling it something different. We're going to call it g of x now instead. But we still start with y equals f of x. Step number 1, change that to a y. Y equals 3x minus 2. Okay? Step number 2. Switch x and y around. Okay, some of you guys go straight to step 2 and that's fine, right? Can you switch f of x and y and then switch x and y at the same time? Some of you guys can do that without writing that first step in there, so that's okay. All right, step number 3, we're solving for y. So what are you going to do first? Just like basic math. Add 2. Plus 2, plus 2. So now I have x plus 2 equals 3y. And then what? Divide by 3. So I have y equals, just leave it as x plus 2 over 3. You can leave it like that, okay? If you want to split that apart, what it will look like is like 1/3 x plus 2/3. That's what that will look like split apart. Did you know that? You split the x over 3 and the 2 over 3 apart, and it'll look like 1/3 x plus 2/3. Yeah. If you write it like that, that's a-okay, but you can just leave it like this if you want to. Okay? And then you switch that back to f inverse of x, or they're wanting us to call it g of x, not f inverse of x. So we call it g of x equals x plus 2 over 3, and that's the answer. He is the inverse of 3x minus 2. If I would graph those two linear functions, they would be reflections of each other across that line y equals x. Okay? Good? No. They wanted us to call it g of x. This is basically the same thing as f inverse of x equals x plus 2 over 3. But they wanted us to call it g of x instead of f inverse of x. Yep. Yeah. If they just said find the inverse, I would call it f inverse of x. But they're saying find g of x, which is the inverse of f of x. So they just wanted us to call it g of x. Whatever. We don't care. All right. So g of x is the inverse. All right. Good? All right, example 3 is a little bit harder than that, just because of like the x's and y's. There's two x's in here. Okay. All right. So let's see. Can we skip the first step and go straight to the second step? This now becomes y, and then we switch the x's and y's around. X equals y squared plus 4y. Okay, that's what the second step is. We're skipping straight to the second step. Now the third step is we have to solve for y. The third step is that we have to solve for y. How do we solve for y when there's two y's there? It's a quadratic. How can we break that thing down and solve for y? Okay. So, when we have a y squared, we can't like detach him from anything on the right side because there'll still be a y left over or anything. Even if we factor a y out, that's not going to work. Okay. So, let's do this. Let's use the quadratic formula. But in order to use the quadratic formula, we have to have 0 over on the other side. So let's do this. This is going to look kind of funny. Let's bump the x to this side. So we have 0 equals y squared plus 4y minus x, okay? Now, the x is kind of like your constant number. Your x is like a number. It's the letter c, okay? You have a, b, c. c is negative x, okay? So when we get to that part, we'll do that, all right? So we're trying to solve for y, and we have our quadratic formula. So negative b plus and minus square root b squared minus 4ac all over 2a. Okay, we're going to factor him down. All right. So b, what is b? No. b is 4. So we have negative 4 plus and minus the square root of b squared is 16 minus 4 times what's a? 1. And c is negative x. Okay, that looks kind of funny, but that's fine. 2a, a is 1. So just to simplify that, negative 4 plus and minus the square root of, what's that going to simplify to be inside of there? 16. But negative 4 times 1 times negative x, what's that make? Plus 4x. And I can't put those two together, so we just leave it like that, all over 2. Okay, there is nothing else that you can do to that. Well, there is something else that you can do to that, but we're just going to leave it like that. Y equals that thing. Did we solve for y? Is it ugly? Yes. Yes. Okay? But that's what he's going to look like. Okay? Good? Beautiful. Beautiful. We could pull a 4 out of that square root and then reduce everything, but we're just going to leave it like that. Okay? We're just going to leave it. We won't reduce. All right. Now, some relations are not functions, and I know we've talked about that in this class before. Relations. What makes a relation a function? How do you know, looking at the graph, if the relation is a function? Yeah, you do the vertical line test. We're going to talk about the horizontal line test here in a second. You do the vertical line test. So if I have a function like this parabola, right? This parabola right here, if I do the vertical line test on him, he's going to pass, right? Good. Function. He is a function. That y equals x squared, this thing that I've graphed right here, is a function, okay? Now, if I tip him on his side, or make him this guy right here, this green guy, which is his inverse, if I do y or x equals y squared, which is his inverse, is that going to pass? No, right? Because he's going to be on his side like this. This is what the inverse is going to look like. And he won't pass the vertical line test, right? So the inverse of that is not going to be a function, okay? Now, if you're looking at this and you're saying, just looking at the original function, if I'm trying to determine whether this guy's inverse is a function rather than doing the vertical line test, I can do the horizontal line test on him. So just looking at that parabola, the one that I had to start with, I can do the horizontal line test on him to see if his inverse is a function. Does that make sense? Okay. Doing the horizontal line test, horizontal line test for the original function is the same thing as doing the vertical line test for the inverse function. Does that make sense? Horizontal line test for the original function is the same as the vertical line test for the inverse function. Yeah? Good? Beautiful? I don't know if this... I wonder if there's like supposed to be a backside. Because I don't think that was it. You think that was it? You can have a square root inside of a square root. Yes, correct. Okay? So if I give you a function like, let's say, y equals the absolute value of x, okay? What does he look like? He looks like a v, right? If you graph him, he looks like a v, okay? Is he a function? Is that v a function? Yes, function. Is the inverse a function? Is the inverse a function? If I do the horizontal line test to determine whether the inverse is a function, does it pass? Does he pass? He hits more than one spot on a horizontal line, right? So no, not a function. Inverse is not a function. He himself is a function, but his inverse is not a function. Does that make sense? Do you know what the inverse of a absolute value of x would look like? X equals the absolute value of y. That's what his inverse would be. He would look like this. He would look like a v, but on its side, right? Kind of like a parabola. The inverse of a parabola is a parabola that's on its side. Good? Yes? Okay, I'm going to tell you one more thing because I know they're going to do this on your homework assignment. Are you ready for this? Okay. Let's say f of x equals x plus 3 and g of x equals x minus 3. Let's say this is your next example. Okay, let's say that you have those two functions. Okay, and I want to determine whether those two functions are inverses. I want to know if those are inverses of each other. Okay, here's what I can do. You should be able to take f composed of g of x and g composed of f of x. You should be able to do both of those things and come out with x as the answer. Okay, so we're going to do that real quick just to see what we get. F composed of g of x and g composed of f of x. Okay, in this left side one, g goes inside of f. Okay, g is this guy. He's going to get plugged inside of f right there. Woo, fuzzy. Come on. There we go. Okay, g is going to get plugged into f. G is the inside function. He's on the inside. So instead of it being x plus 3, x minus 3 is going inside of there. Yeah? Okay, now, negative 3 and plus 3 are going to cancel out. Does that equal x? Yes, good. Okay, now we're going to do the other one. G composed of f of x. So this guy is going to get plugged into here where the x is. So instead of it being x minus 3, x plus 3 is going inside of there. Yeah, what happens here? Those two are going to cross out. Does that equal x? Yes. So when it crosses out for both compositions, whether you switch whichever ones you switch it around, when it comes out to be x on both sides, f of x and g of x are inverses. They are inverse functions. Okay? You should be able to do composition of both of them and switch them around, and as long as it comes out to be x for both of them, then they are inverses of each other, okay? People get this screwed around all the time because, don't write this down, People get this screwed around all the time because they say, this one comes out to be 2 when I simplify, and this one also comes out to be 2 when I simplify. So since they ended up being the same thing, once everything all crossed out, they're inverses of each other. No, it's not that these two things end up being the same thing. They have to be x when you cross them out, okay? And you know the reason why they have to be x when you cross them out? Your magical line that they are reflected over is the line y equals x. That's where that comes from. So when you compose one inside of the other and vice versa, you should come out to be x for both pieces if they are truly inverses of each other. That's a way to check. I can remember McCoy Minky sat here in calculus because we do inverses in calculus again. And he's like, well, why wouldn't you just do this? Why wouldn't you just start with this function, do the 4 steps, and see if it comes out to be that one? Sure, why not? Go for it. If you can't remember to compose one inside of the other, that's great. Okay, you can sure do that. Take this one, start with that one, do the 4 steps, and get to that one. But this is the rule that f composed of g of x should come out to be x, g composed of f of x should come out to be x. If both of them do, then they are inverses. If this one doesn't come out to be x, don't even check this one. Because if one of them fails, the whole thing's going to fail, right? Don't go to all that extra work. If this one fails, they're not inverses, right? Now, if this one passes, does this one always pass? No. Like 99% of the time, it's going to pass. But there's like a couple functions that this one passes, but this one doesn't pass. So just be careful of that, all right? You do need to check both sides. All right? Good? That's it.